Alright, this is question 6, homework number 4. Alright, so the first question is asking us the frictional force on the block from the floor. So recall that friction is the coefficient of friction times normal force. Here it happens to be kinetic friction, doesn't really matter in this case. So we're given that. So the normal force we can figure out is mg plus sine theta of 20, the force, how hard it's pushed, sine theta. It might differ depending. And why sine? Well, if we take a look at this, this is the force that's given, like you're pushing onto it. So whenever you have a magnitude, always split it into x and y and consider them separately. It's the most important thing to know. So opposite hypotenuse is sine, and as you can notice, this is pushing down. And normal force will match it and it'll push back up. So we know it's mg plus 20 sine theta. That's why it's plus, by the way, not minus. And then mg is just gravity. Normal force always counteracts gravity. So since normal force is equal to the force down, it's gravity plus whatever number you got, sine theta. And then you should find the normal force. Once you found the normal force, just multiply it by your coefficient of friction, whatever it is, and that will give you the force and friction. And then that would give you the answer for part A, frictional force on the block. And then for the acceleration, or for number B, remember, I think it's Newton's second law, force equals mass times acceleration. So the force on the block, using the same picture from before, we can figure out is 20 cosine theta minus friction. Why minus friction? Because friction always opposes your movement. That's what friction is. So it's cosine because it's adjacent and opposite. And see, this angle is pushing this way. So if you do the math, you should get about 15 something. Well, it depends. But then what you do is you take the force on the block, which you found, which is this, right here, and you minus your friction from part A. So in my case, like 15.3 minus whatever I got from part A, and that gives me the force. And then to find the acceleration, you just plug it into F equals m times A. You know F now. You know you know M. You can find A. And if you do the math, it should get you the answer.